In this video, I'm going to solve this question. A well-designed and safe workplace can contribute greatly to increased productivity. It is especially important that workers not be asked to perform tasks such as lifting that exceed their capabilities. The accompanying data on maximum weight of lift, which we are calling MAWL, for a frequency of 4 lifts per minute was reported in this article. Subjects were randomly selected from the population of healthy males ages 18 to 30. Assuming that MAWL is normally distributed, does the data suggest that the population mean MAWL exceeds 25? Carry out a test using a significance level of 0.05. And this is the data that we are given. So first of all, let's define the null and alternative hypothesis. Note that we are given in the question that we have to check whether the population mean MAWL exceeds 25 or not. So I'm denoting the population mean MAWL by mu, and this is the claim that we have to test, that mu is greater than 25. Now the counter claim is mu less than equal to 25. So these are the two claims that we have. As this claim has an equal to sign, so that means we can take this claim as our null hypothesis, and consequently this claim is our alternative hypothesis. Note that you can also write null hypothesis as mu equal to 25. So this is some notation that we can follow. We can replace less than equal to with equal to. Now let's move to step 2. So this was our step 1. In the step 2, we have to write all the information that has been provided in the question. So we are given that we have to test using a significance level of 0.05. So alpha is equal to 0.05. And we are not given the direct values of sample mean and sample standard deviation, but we are given this data. So we can use this data to find the value of sample mean and sample standard deviation. So let's start with sample mean. So I'm denoting sample mean by x bar. So x bar is equal to x1 plus x2 plus x3 plus x4 plus x5 divided by 5. So that means x bar is equal to 25.8 plus 36.6 plus 27.2 divided by 5. And this is equal to 27.54. So the sample mean is 27.54. Now let us calculate the sample standard deviation. So I'm denoting the sample standard deviation by S, and we know that the formula to calculate sample standard deviation is equal to summation xi minus x bar whole square divided by n minus 1. So this is the formula to calculate sample standard deviation, and this is equal to under root of 25.8, which is our first observation, minus the mean value, so 27.54 whole square, plus 36.6, which is the second observation, minus 27.54 whole square, and so on till the fifth observation. And then we have to divide this by n minus 1. So our n is equal to 5. So this is 5 minus 1. Solving this, we get that the sample standard deviation is equal to 5.47. So this is the sample standard deviation. Now let's move to step number 3. Note that in the alternate hypothesis, we have a greater than sign. So that means this is a case of right-tailed test. So this is a case of right-tailed test. And we are also given in the question that the population is normally distributed. Well, note that because the population is normally distributed and the sample size is small, like the sample size is less than 30, so we will use t-test in this case. So let's say this is how the t-distribution looks like. And we are given that alpha is equal to 0.05. Now because this is a right tail test, our rejection region will be somewhere here, and this is 0.05. So the probability that the t value will lie in this area is 0.05. So to test this hypothesis using the t statistic, we have to calculate two things. One is t calculated which is the t value that we will calculate, and the other is t critical. And this value is what we call t critical. So the t value here is t critical. So first of all, let's find t calculated. So t calculated is equal to x bar minus mu divided by sample standard deviation divided by under root of n. So this is the formula to calculate the value of t. Note that the mu value that we are going to write here is the value of mu under the null hypothesis. So we calculated that x bar is 27.54 and the value of mu under the null hypothesis is 25. So we can write 25 here. Our sample standard deviation is 5.47. This is what we calculated, and divided by under root of 5 because our n is equal to 5. And from here we get that t calculated is equal to 1.038. So this is what our t calculated is. Now there is one important thing that you should always keep in mind, that we are using t-test in this case because the sample size is small and the population is normal. So we are given in the question that the population is normally distributed. Say for example, if you encounter a question in which the population is not normally distributed and your n is less than 30, in those cases you cannot use t-test. So in those cases you will have to use some other tests which do not depend on the distribution of the population. Okay, but in this question we can use t-test because n is less than 30 and we are given that the population is normal. So the condition is that if n is less than 30, the population should be normal, or say approximately normal, if you want to use t-test. Otherwise you cannot. So let's proceed further with our calculations. So this is what t calculated is. So t calculated is equal to 1.038. Now let us find the value of t critical. Well, we can find the value of t critical by looking at the t table. So in the t table you have to look for that value of t where alpha is equal to 0.05 and degrees of freedom is equal to 4. Well, degree of freedom is 4 because when we use t, the degrees of freedom that we have are n minus 1. So this is the degrees of freedom, and because n is equal to 5 in this case, so the degrees of freedom are 4. So after looking at the t table, when alpha equal to 0.05 and degree of freedom equal to 4, you will find that the t critical value is equal to 2.132. And note that the t calculated is 1.038. So t calculated will be somewhere here. So 1.038 will be somewhere here. As your t calculated lies to the left of t critical, we do not reject the null hypothesis in this case. So we can say that the conclusion is we do not reject the null hypothesis. So do not reject null hypothesis when alpha is equal to 0.05. So this means that there is not sufficient evidence to conclude that the population mean is greater than 25. And this is all for this question.